A very warm and a pleasant morning to you all children. I welcome you all for today's learning session. Children, we have completed almost 80% of our syllabus, and what remains is 2 chapters in physics and 1 chapter in chemistry. So I will be dealing with you a small amount of teaching and a major amount of work will go for the revision. Right children, today we are going to start a new lesson called Work and Energy. This is a very interesting lesson and it involves most of the problems which you have to solve. Now in this chapter, Work and Energy, in today we are going to see what is work. Work in science is entirely different from the usual word which is uttered by many. For example, the mother, after a tedious work in the kitchen, she will come and grumble, what a tremendous work or a tedious work I had. Similarly, you might have seen your father saying sometimes, in the office, I had a hectic work. So, is this work which we use normally is same in science? No. The work in science is entirely different. So we are going to see what is work, how is work calculated, and the types of force, positive work, negative work, and zero work. So these we are going to analyze in today's class. Okay, now we will go into the lesson to learn in detail. Yes, children, now let us see what is work in science. See to the definition here. Work is said to be done only when a force acts on an object and displaces it or makes it to move. So again, work is said to be done only when a force acts on an object and displaces it or makes it to move. So, if at all work has to be done, a force must act on the body and the force must displace the object. So, both the things should happen. So, see to the next one. 2 conditions required for work done. A force should act on the object must be displaced. So when these two are happening, then we say work is said to be done. Now for example, if you try to push a wall, you are applying a force, but the wall doesn't move to make a displacement. In this case, you are doing no work. No work is said to be done by you. At the same time, if you open the door of the room, you apply a force, and because of the force, the door displaces or moves to a distance. Here, force is created or exerted on the body, and the force makes the body to move a distance. So these two things are happening. So work is done by you in moving the door. But at the same time, work is not done when you push a wall. If any one of the above condition does not exist, then work is not done. If the force is absent, work is not done. If there is no displacement, there is no work done. Now see to the pictures in this here. the first picture, the girl. No work is done. Force is applied, but no displacement. See to the girl. The girl is taking or lifting a chair. She is applying the force, but there is no displacement in the chair. The chair is not moving. Therefore, no work is done. See to the boy where he is handling a bat and a ball. Force applied on the ball and it moves. Work done on the ball by the batsman. So force is there, and because of the force, the ball moves a distance. Therefore, there is a work said to be done in this situation. So let us conclude. What the definition of work? Work is said to be done when a force acts on a body and makes it to move through a distance. Now, in this slide, let us see how can we calculate the work done. What is the formula for calculating the work done? Go through the slide. Work done by a force on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of force. So we have seen in the earlier definition, for work done, there must be a force and there must be a displacement. So work done can be calculated if we know both the quantities, force and displacement. If we multiply both of them, then the product that we get is work done. Now see to the example given here. In a table, an object is there at the position A and a force is applied for the object to move, and because of the force, the object A is displaced to a new position B, and the distance between A and B, or the displacement, is F. So this can be the example given on the right side of the figure. It can be for a toy car being pulled by a girl to move it to a new position. Because of the force, the car changes its position from A to B. Let us assume if a constant force F acts on an object at a point A, due to which the object gets displaced through a distance S in the direction of the force, and then it reaches at the point B, then the work done W by the force F on the object will be equal to the product. Product means multiplication of the force and displacement. Work done is equal to force into displacement in the direction of the force. So work done is kept by the letter W, force is kept by the letter F, and displacement is kept by the letter S. Therefore, W is equal to F into S. This is a very important formula which enables us to calculate the work done in any case. Now, let us apply the formula in solving one of the numerals in your textbooks. So the formula is work done is equal to force into displacement. W is equal to F into S. Question. A force of 7 Newton acts on an object. The displacement is, say, 8 meters in the direction of the force. Let us take this that the force acts on the body through the displacement. What is the work done in this case? So you are given with two numbers, 7 Newton and 8 meters. 7 Newton represents the force, that is F, and 8 meters represents the displacement. So you are asked to calculate the work done. What is the work done? Therefore, apply the formula. W is equal to F into S. So F is 7 and S is 8. So multiply both of them, 7 8s are 56. Now we come to an important aspect here, the unit. What is the unit of work done? So from the formula, F into S, F has a unit, Newton, and S has a unit, meter. Therefore, Newton meter is the unit of work done. But we keep joule as the SI unit of work done. So 1 joule is equal to 1 Newton into 1 meter. We will see in the next slide. Let us see to the definition of joule in this slide. The SI unit of work done is joule. So previously we had seen how much is 1 joule. 1 joule is equal to 1 Newton into 1 meter, where 1 Newton represents the force and 1 meter represents the displacement. 1 joule of work is done when a force of 1 Newton moves an object through a distance of 1 meter in the same direction of the force. So this definition for joule is a very important definition. So how will you define a joule? What is joule? A joule is the SI unit of work, and define a joule. 1 joule of work is done when a force of 1 Newton moves an object through a distance of 1 meter in the direction of the force. This slide again explains you in a very clear manner the SI unit of work. So if F is equal to 1 Newton and S equal to 1 meter, then the work done by the force will be 1 Newton meter. The SI unit of work is Newton meter, which is also called joule. Thus, 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. So 1 joule is equal to 1 Newton into 1 meter, that is equal to 1 joule. Work done is a scalar quantity. You have to remember this. It is a scalar quantity because it has only magnitude and it has no direction. There is a problem also given in this slide. A force of 10 Newton is acting on an object. The object is displaced through 5 meters in the direction of force. What is the work done in this case? So 10 Newton is the force and 5 meters is the displacement. So work done is equal to force into displacement, 10 into 5, therefore 50 joules. The amount of work done in this case is 50 joules. Children, let us pass on to the type of work done depending upon the angles they make. Work done may be positive, 0 or negative depending on the angle between the force and the displacement. Now carefully look into the diagrams which is given here. Now the blue color line represents the displacement and the red color line represents the direction of the force. Now there are 3 types of angles formed here. The first is acute angle, The second case, it is right angle which is equal to 90 degrees. And in the third case, it is more than 90 degrees. Therefore, it is obtuse angle. So, when the force and displacement are acute angled less than 90, then the work said to be is positive. When the angle made by the force and the displacement are exactly 90 degrees, then we say the work done by the force is 0. When the force makes more than 90, that is obtuse an angle, then the work done in this case, it is negative. So, work done may be positive, negative or 0. When the angles are acute, work done is positive. When the angles are obtuse, the work done is negative, and the angle is right angle, then the work done is 0. We will analyze the type of work done, that is positive work done, negative work done and 0 work done more deeply. When the force F and the displacement S are in the same direction, angle between the direction of the force and the displacement here is 0. Work done will be positive. That is, work is done by the force. Example, take the case of a boy who pulls an object towards himself. So you would have seen some toy cars being pulled by the children. So in this case, the direction of the pull is same as the direction of the cart moving. So the direction of the force is the direction of movement of the object. Both the directions are one and the same. So here the work done is positive. So both the directions are one and the same. The direction of the force and the direction of the displacement. Now let us go to the next one. When the force and the displacement are in opposite direction. So when they are in opposite direction, the angle made between the direction of the force and the displacement is 180, a straight line. Work done will be negative. That is, work done against the force. Example, frictional force acts in the direction opposite to the direction of the displacement. So, work done by the frictional force will be negative. So, we had studied a lot about friction. We have studied friction is an opposing force which acts in the opposite direction of the movement of the body. When the car moves in the forward direction, there exists a frictional force between the tire and the road. And this frictional force is in a direction opposite to the direction of the movement of the car. So, here the movement of the car and the direction of the frictional force both are in the opposite direction. So, in this case, the work done is negative. And we'll go to the third case. When the force and the displacement are in perpendicular direction, that means the angle between the direction of the force and the displacement is exactly 90 degrees, work done is 0. So let us see to the example here. A coolie carrying a load on his head. In this case, gravitational force is acting vertically downward and the displacement is acting horizontal direction. That is, the force and the displacement are perpendicular to each other. So this case work done is 0. So here is the angle 90 degrees when he carries the load on his head. Okay, so the work done here is 0. Children, we will apply with an example to get more clear about the type of work, positive, negative and 0. Now look into the first example. Here a man pushes a cart. He pushes the cart in the forward direction and therefore the trolley also moves in the forward direction. So the direction of the force is same as the direction of the displacement. Therefore, since both the directions are same, then the work done here in this case is said to be positive. Now look at the same trolley here in the second picture. The man pushes the trolley forward, therefore the direction of the displacement is in the forward direction. When the trolley moves forward, the wheels of the trolley, which are in contact with the floor, they exert frictional force. And you all know that the frictional force is in a direction opposite to the direction of the movement. Therefore, the frictional force is in the opposite direction to the direction of movement of the trolley. Here, frictional force is acting on the left and the direction of movement of the cart is on the right. Therefore, exactly they are in opposite direction. Therefore, the work done here is said to be negative. Now, go to the third case where the work done is 0. Here you can see a man carrying a luggage and walking through a distance. He carries a load on his hand and he is moving forward. Actually, you will say in ordinary language, he is doing a lot of work. But here in science, we say no work is done by this man. Why? Now, when he lifts the box or the luggage, the gravitational force is acting downward. And the direction of the movement of the man is in the forward direction. So combine both the direction, the gravitational force as well as the direction of movement of the man. Both of them are at an angle exactly 90 degrees. So when it is at 90 degrees, then no work is done by it. The work done is said to be 0 when the body is displaced perpendicular to the force. Therefore, work done in this case is 0. Hope you would have understood what is positive work done, negative work done, and when the work done is 0. This slide gives you various examples for the positive work done. Kicking a football. When you kick, the force given by you and the displacement of the ball both will be in the same direction. Moving a chair. So similarly, the force and displacement will be in the same direction. So you can imagine in each of the case here, throwing a stone, riding a bicycle, doctors moving a patient in wheelchair, striking a pen into another pen, riding a skateboard, pushing and moving a table, cutting a fruit with knife, a car moving forward. So all these are the examples which we can illustrate for positive work done. So in each of the case, you imagine yourself the direction of the force and the direction of the displacement, and imagine both of them go hand in hand in the same direction. Here are some examples which illustrates you for negative work done. Here in each of the case, you have to understand that the direction of the force and the direction of the displacement are exactly in opposite direction. So let me give you an example which is not there in the slide. Catching a ball. When a ball, when a batsman is striking the ball, and if you are about to catch that ball, then you are doing negative work done, because the force or the movement of the ball is in the forward direction. You apply force in the opposite direction in such a way to stop the ball. So the force and the displacement of the ball, both of them are in the opposite direction. Therefore, the work done here is negative. Supposing if you are lifting any article or object from the floor, then the work done by you is negative, because when you take an object from the floor, you are applying a force against the gravity. So the moment of the or the displacement of the object is in the upward direction, whereas the direction of the movement of the gravitational force is in the downward direction, which are exactly opposite. Therefore, the work done in this case also is negative. So quite a few examples are being given here. So just analyze them and know that all of them comes under negative work done. Here is another example which we can illustrate for the work done is zero. A man carries a bucket of water horizontally at constant velocity. So he carries the bucket and moves horizontally. The force does no work on the bucket. The displacement is horizontal. Force is vertical. So the force and the displacement. The force is horizontal and there is a gravitational force acting on it downwards. So as we had seen in the case of a man carrying a luggage and moving forward, here the luggage is nothing but here it is a bucket of water. Therefore, the work done in this case is zero. Now, let us summarize it more clearly for positive, negative, and no work done or zero work done. If the displacement is in the direction of the force, then W is equal to F into S, where it is the positive work done. If the displacement is in the direction opposite to the force, both the directions are in opposite way, then the work done here is negative. If the displacement is perpendicular to the force, work done here is zero. Now we pass on to solving numerals in this work done. Find out the work done when a force of 20 Newton displaces a body through 8 meters in the direction of the applied force. So the given quantities are force 20 newtons and displacement 8 meters. And what we are asked to calculate is work done. So first write the formula. So for all the problems, you should start with formulas and end in SI unit. This concept you have to remember. Start solving every problem with the formula and end the problem with the SI unit. So to start with, the formula is work done is equal to force into displacement. So 20 into 8, so 160, and the SI unit is joule. Second question. A magnetic crane lifts a mass of that much through a vertical height of 40 meters. Calculate the work done in operating the crane. G is to be 9.8. Here we have to calculate the force. F is equal to mg, where it comes from. F is equal to ma, acceleration. Here g is the acceleration. So mass is given as 1500 kilograms and the g value is given here as 9.8. So with that we calculate the force. It comes to be 14,700 newtons. So work done is equal to force into distance. So apply the numerals and get solved. So you get the answer as 588,000 joules. So now we will see one more example here. Question number 3. 5,900 joules of work is done by a machine to lift a mass of 100 kilogram vertically upward. Calculate the height to which the mass is lifted upward. Calculate the height. The height here is the displacement. So S, in the formula W is equal to F into S, you have to calculate S. Now what is being given? Mass is given as 100 kilograms. Therefore find the force. So as in the previous case, F is equal to mg. So 100 into 9.8, 980 newtons. Then applying the formula W is equal to F into S. S is equal to W by F. So W value is 5,900 divided by 980. So when you simplify, you get 6.02 meters. Since displacement is being asked, the SI unit of displacement is meters. Question number 4, actually we are yet to learn kinetic energy. So after learning kinetic energy, you will understand this question. So wait for the next class to get understand with this question. Okay. Children, by this we come to an end of today's learning section. Today I have covered only a small subtopic, that is work done. In this work done, we have seen the definition of work done, how to calculate the work done from the formula, what are the types of work done, how can we identify the work done as positive, negative or zero, and how to solve numerals. Only these concepts we have covered today, and the rest of the chapters will be taken up in the upcoming classes. As I told you, I had given you only a few subtopics today, and because we have to revise what has been done so far. So children, I will be giving you a test, in the sense I will be giving you the questions for which you have to write the answers as test in order to recall your answers. Only when you are in contact with the chapters which have been done, you will be remembering it. Otherwise, you will lose memorizing them, right? Therefore, I will give you those assignments separately, and so cooperate, and because I hope we will be reopening the school very shortly, and we are waiting for the orders from the officials. Okay, children. So until then, keep learning yourself, keep engaged yourself, and be safe yourself. Thank you, children.